Hello class, this is me, Mr. Wee. It's going to be the last example that I'm going to go through for 9-3, and then we're going to move on to 9-4 in the next video. So I'm going to go through a problem. This section is aptly called the parts of similar triangles. There are two triangles embedded in here. If you can see it, it's kind of color coded. So why don't you take a minute to actually copy this down. You can pause it really quick just to copy this down, and there's a task here to find B and E. You can actually also work on this if you want with a partner on a whiteboard. Or you can just watch me and take some notes, and then I'm going to give you another problem following this to try to solve. So the first step in solving this is to actually, I would say to separate, well, first before you separate the triangles, do you see two similar triangles? Well, I do. So actually, yeah, let's go ahead and separate it out. I color coded this in red intentionally. So I have a triangle here from base A to E, kind of off-center B here. So we'll say that's B, E, and this is A, so that's going to be Y, this is going to be X, it's going to be 3. And the bigger triangle, I'm going to color code in blue, to A to C to D. Same sort of setup, but it's just a little bit bigger. Be A, C, D. And I'm going to say that, oh, AC is given to me as 5. CD is 3.5. This one's a little bit trickier on the bottom. This is actually ED plus AE on the bottom here. So that's going to be Y plus 3 in all technicality. So it's really nice to separate out the triangles. I mean, you don't have to do it. You can just kind of go off of what you see by eye. But it's nice to separate them out so you see exactly what you're dealing with. And the thing is, before you can do anything, you want to start, because we're going to start using, setting up the ratios. Like I can already see BE is proportional to CD, and I also know AB is proportional to AC. But the only way you're going to know that is if these two triangles are actually similar, and they actually are. I think the first one you might recognize is that they both share an angle. Angle A and angle A on both the triangles are the same. It's the reflexive property. So they're actually both the same. So we have one angle, and here's one that you might not know that they actually specify in the book, and I don't think it's very clear, but because you have two parallel lines here and here, and these two lines are essentially parallel, so let me write that in black. CD and BE are parallel. What they actually say in the book is that this angle is going to be equal to this angle. So let's see, ABE is congruent to A to C to D. So these two angles are actually congruent, and that's what the book specifies there. So if I get that right, B to C to D, B to C to D, yes. And I believe in the same token, if you want to know, so basically you could stop right there if you want. You have two sets of angles that are congruent to each other, making these two triangles officially similar now. So now we can start making ratios, but if you just had to know, the same logic follows that within this triangle, AEB, because these are two parallel lines. And it's so funny because in the book they don't even have a theorem for this, but because these two triangles are actually or these two sides are actually parallel, it seems to be that AEB is also congruent to this bigger triangle, A to D to C. 2, 3. So these corners here. Now you don't have to prove that they're similar to me. If I give you a problem like this on the exam, you can just kind of see that I imply that they're both similar. So I'm not going to try to trick you. Okay. So at this point, I know that they're similar to each other. It's just now I got to solve for X, or I want to solve for BE, which is essentially X, and AD, which that means I have to solve for Y. So basically, let's go ahead and set up some things. I know that AB is comparable to AC. AB and AC are comparable to each other. So they're corresponding parts. I think they're parts of similar triangles. These are similar triangles and they're corresponding parts. And I have a definitive number, 3 and 5. So AB over AC, I think, is going to be equal to, let's say, BE in the way that BE compares to CD. And all I have to do is simply, CD is going to have to be blue. That's CD. And then what I'm going to have to do is I'm going to substitute in the values for AB is going to be 3. and AC is going to be 5. I'll set that equal to BE, which is X. Color code that in red, which is technically X, divided by CD, which is in 3.5. Oh, sorry about that. Let me move that up. There we are. And then I simply cross multiply now. Cross multiply to solve for X, and that's going to give me, let's see, I'm going to stop color coding now. It's going to be 5X is equal to 3 times 3.5. And 5x will then be equal to, I believe, 10.5, if you do the math. Am I doing that correct here? I believe so. So let's see, 3. Let me just do it off to the side here. 5, 1. Yep, that's 10.5. Okay. Sorry, I just don't like to leave notes on the side like that. So just so I don't have too much clutter. It's nice and clean for you guys to see. And then if you divide both sides by 5 to isolate x, to get x by itself, you will find that x is equal to 2.1. And since BE is equal to x, you found that BE is then 2.1. That answers part of the first question. Find BE, or the first command. It's not a question. Then you got to find AD. So all you have to do now is, again, I like to use, so let's just say that was just to solve for BE. We'll separate this side into BE, and we're going to separate this right side into solving for AD. And how we're going to do that is I'm going to use not anything with the variable, because who knows, maybe my x was wrong. I don't want to use the ratio with anything that I just solved for. I want to use a ratio that has defined nice numbers, no variables, no arguments. AB divided by AC, those are definitive whole numbers without any variables, and I want to use a ratio that only has given whole numbers with no variables that I had to solve for, because potentially if I solve for x incorrectly, then I would be using an incorrect ratio. So 3 and 5 are definite good numbers, and it would form a ratio that I want to use to eventually solve for this ratio. How AE corresponds to AD. AE corresponds to AD. And let's go ahead and plug in some values here. And don't be afraid, okay? I know you got some y and a y plus 3, but go ahead and just plug in what you got. Which actually is a good general advice in math. It's the first step is just taking risk and plugging in numbers and seeing what you can do. Trying to make conclusions the best way you can just by writing down things. And then just seeing how it all unfolds. So 3 will be comparable to 5. Plug in 5 for AC, and then you set that equal to AE, which is going to be y, divided by y plus 3. So AE is comparable to AD, so y is going to be equal to y plus 3. So don't be afraid. Don't be scared. And what we're going to do is we're going to cross multiply, and then what we'll end up having is 3 times y plus 3. That's not so bad. That's not so bad. It's equal to 5 times y, which is just 5y. And then if I distribute the 3 on the outside of the parentheses here, then I have 3y plus 3 times 3 is 9 is equal to 5y. I'm going to isolate y. I'm going to have y on just one side. So I'm going to subtract all the y's on this side, because that's a lower number of y's. And I'm going to subtract 3y from this side. I'm going to have 9 is equal to 2y. Then I divide both sides by 2, so that way I can just get y by itself. That would be about 4.5 if you did this correctly. However, you're not answering the question yet. I'm asking you to solve for AD. AD is y plus 3, so AD is technically y plus 3. And then I just solve for y, which is 4.5, so I'm going to substitute that in. And then I have officially solved this problem. AD is now equal to 7.5, and BE is going to be equal to 2.1. Those are your final answers, and I'm going to give you one sample problem for you to try out. You can stop here if you want, but I'm going to keep going. I'm going to do 2 parallel lines here, seemingly, and I'm going to kind of crisscross them to different vertices here and here. Okay. And then I'm going to call this SW, middle point is R, T and V. Okay. And then I'm going to go ahead and color code this to be 8, and this is going to be X plus 6. And then over here in the blue will be 2X plus 6 and 10. So you can kind of see that these two triangles, well, I imply that they're similar, but just to double check, let's see if I can. Oh, and I think in this, it's given that these two angles are congruent to each other. And if you, what's not given to you is if these two triangles are similar before we do anything. Are they similar? And then you can say yes, because Mr. Wee, I don't know if these sides are actually proportional, SW and TV, but I know that because I see vertical angles, that makes these two angles congruent to each other and these two angles. So again, by the AA similarity theorem, I can say that they're similar. So now that they're similar, because they both have two sets of angles that are similar to each other, I know that these two triangles are similar. And now I can actually solve for, oh, this is what the question was asking. Can you find the measures for WR and, that's an ampersand for and, sorry, it's a little ugly, RT, okay? And we can start comparing the ratios to each other only because we know these triangles are officially similar. So I know that SW is comparable to, color code that in blue, TV. Okay, so 8 over 10, these two sides are corresponding to each other. In the same way that I think WR and RT compare to each other. Okay, so WR, the smaller triangle side, to the bigger triangle side, which is RT. I think this will be a nice, quick, short one. Okay. Again, if you want, just go ahead and pause and try this out before I walk you through this. But I just wanted to show you a quick one. And then what you're going to do is now you're going to substitute in some values. So SW is 8. TV is, I'm sorry, not T, yeah, TV is 10. That's going to be set equal to WR, which is X plus 6 divided by RT, which is 2X plus 6. We're going to cross multiply these values, and you're going to have 10 times X plus 6 is equal to 8 times 2X plus 6, and then you're going to do the distributive property in here and here. That will get you 10X plus 60. And then 8 times 2x is 16x plus 8 times 6 is 48. Okay. And then what I'm going to do is I'm going to subtract 10x from both sides. So that way it leaves me with x only on one of the sides of the equality sign. So that 60 is equal to 6x is plus 48. Then I'm going to set the whole numbers on one side by subtracting 48 away from here and only isolate my x value on the right side. Whatever I do to one side of the equal sign, I got to do the other. So that's going to be 12 is equal to 6x. And then I divide both sides by 6, and x will then be equal to 2. That is not the final answer, however. That just helps me to find WR and RT. So with the fact that x is equal to 2, let's go ahead and maybe start another column of work here. I'm going to say that WR, I know for a fact, is given to me as x plus 6. And I know x I just solved is 2. So now that gives me WR is 8. There we are. And then RT is equal to 2x plus 6. So RT is equal to 2x plus 6. And I know that my x, again, I solved down here was 2. So I'm going to write in 2 times 2 plus 6. 4 plus 6, that will give me a value of 10, making RT equal to 10. If you want to double check, let's just see. Again, we know that WR is equal to RT. We can plug that back in. You don't have to do this step, but let's just double check. WR we solved is 8, RT is 10, and then SW is 8 and 10. as well. If you look closely, are these two ratios of SW over TV and WR over RT equal to each other? Yes, they are. They're exactly the same, 8 over 10. If you simplify that even further, I know that 2 is the greatest common factor in 8 and 10, so 8 divided by 2 is 4, and then 10 divided by 2 is 5. No matter how you slice it or reduce it, they're still going to be the same ratios, okay? Meaning that we have done our work correctly, because if these two triangles were similar, then the x value should be equal to 2, making both of these sides make a ratio that's proportional to the ratio of SW and TV. Okay? All right, guys. You guys have a great day. In case it's the end of class, but I have more parts coming up for 9-3 or 9-4 that I'm going to slowly upload. Okay? This is going to be the end of 9-3. We're going to move on to 9-4 in the next video if you keep joining me. Okay, you guys have a wonderful day. I'm going to go ahead and stop the video.